Good afternoon, everybody, and welcome to Zahn Academy. Today's webinar is 3Shape design of removable partials and flippers. We have today Alex DeVos, who's joining us, and he is a CAD/CAM technical trainer for Zahn Dental. Thank you so much, Alex, for joining us. Today we have a few poll questions for you, and two of which I'm going to launch before we get started, so we know exactly who we're speaking with here as our attendees. So I'm going to launch one of those questions now. If you wouldn't mind, please be interactive with us because we really want to know what you're up to out there. So the first poll question is, do you design in-house or outsource? If you wouldn't mind, just checking out. And Alex, why don't you tell us a little bit about yourself while we're doing this poll?
Yeah, thanks for joining, everyone. My name's Alex DeVos. I'm one of the main trainers at Zahn for the programs and equipment. I've been with Zahn for about 11 years now, working with 3Shape and Roland at first, but I've been training our customers for about 9 of those. For this year in particular, we've had quite a few trainings, both one-on-one on-sites and throughout all of our road shows and classes. Just this last week, we got back from a really nice denture class we did in Florida, where we did a bit of design and hands-on finishing with the printed dentures. So definitely throughout the coming year, keep your eyes peeled for any road shows or classes that we've got planned, because we're looking to get those plugged in shortly.
Absolutely. We're going to be, coming to city near you, and we're also going to be having some of those courses at our technical center over in Massachusetts, which is like 20 minutes out of Boston. So really nice area to visit. But we do have the results for this first one. And Alex, it seems that 79% of our attendees are in-house designers and 21% outsourced. So that's really cool.
All righty.
Now we're going to launch our second question. And I'd like to know, do you design in 3Shape as a beginner, an intermediate, or an expert? You guys wouldn't mind answering those. We appreciate it so much.
Yeah, so today we're going to be going over partial design in particular. We'll be discussing all of the different tools we'll use for various types of partials, but the main two we're going to be focusing on are the flippers and a little bit of the traditional partial tools.
Great. So we have the results. So 55% are beginners. Okay. 36% are intermediate designers and 9% are experts. Okay. So there you go, Alex. So now we know who our attendees are. And I want to thank all of you so much for taking part of these polls and being interactive with us. Here's Alex, and enjoy.
Yeah. Thanks again for joining, everyone. One last thing before we jump into the design workflow. If you could just find on your screen the Q&A or chat section. As we go through the training, don't be shy. Feel free to jot down any questions or comments you want to log in there. And at the end, after we're finished with the workflow, we have some time set aside to address any questions or info you'd want. But as we continue, so I'm going to minimize this window here, and I've got 3Shape Dental Manager already open here. Before I jump into the design, I'm going to right-click and modify this case, just so I can go over the order setup. So let me clear this out just to show the example. So for partials in general, they have a specific section exclusive to them, but there are a couple different things to keep in mind with the order setup. For this case in particular, it's set up for a flipper, but I do have a couple other teeth extracted here that will pretend that we're doing a traditional partial as well, just in this one area, just to practice with some of the other tools. With the main setup, I would click any tooth on the arch I'm interested in and go to the removable section. If I leave it as just this option here, RPD across the entire arch, this would be considered our traditional metal framework. In the order form, we don't specify where any specific clasps or minor connectors are going to be placed because that's all done wherever we want once we get into the design workflow. The only things that I would want to label specifically by tooth number is if I do have any tooth or anatomy I want to include as part of the partial design. So let's say for number 8, I'll click that and go to the anatomy section. And it defaults to our last option, artificial tooth, and that means that the tooth we design is going to be completely separate from the base of the framework. So it'll essentially have our base in our gingiva color with a socket for the separate tooth colored tooth. If I were doing a traditional partial where I wanted one of the teeth to be metal as well, instead of artificial tooth where it's separate, I would do Pontic, where it's combined together. You could even do in the framework section an anatomical Pontic, where it'll have a facial cutback if you want to go that far. But for this case today, we're going to leave it as a separate piece. One other thing to note, I believe in the 2022 version, they introduced this where you can use the denture workflow to design partials in this way. And there are some advantages to that, though personally, I do find I have a little bit more flexibility and features if I use the removable workflow. The setup for that would be very similar. You would just go in the gingiva section and choose denture. Even though it's not highlighting for the entire arch, we'll be able to pick and choose where we want the base to be placed all the way around. So I'm going to leave it as the removable plus artificial tooth. And I'm going to hit cancel so it goes back to the original setup. So let's right click and jump into the design. So one thing to note with most designs in 3Shape, there are a couple steps that are skipped by default. And those are typically this section here where we can modify or edit the scan data. So if this did not already have teeth removed or extracted, I could go in and virtually extract them with this tool here. Not that we need that for this case, but it's a quick way to remove some material. But the first step it wants from us is to label the tooth number. So over on the left, we've got our instruction, select artificial tooth number 8. So I'm just going to zoom in and left click roughly the middle of where that's going to sit. After that, I'll continue next and it takes us to an insertion direction step, which if you've worked with partials or dentures, you're probably already familiar with this layout. But if you're more familiar with the fixed restorative side of things, some of the tools will work similar, but the way it shows the undercuts is a little bit different. The default direction it comes up with is almost never correct. It's mainly just the angle that the model was when it was scanned in. But based on the current angle, it's highlighting different areas from yellow to red based on how deep the undercuts are. The more shallow undercuts are the yellow region, up to 0.25 undercut, and the deepest areas are anything more than 0.75 millimeters undercut in red. But like pretty much every insertion direction step in 3Shape for any workflow, it's generally a good rule of thumb to completely change your insertion path at first based on your view. So I'm going to rotate my view to where I think this partial would best seat from. And in particular for this type of flipper, I'm going to try and find an angle where I can see a little bit of the contact walls as well. Once I think I've found the right angle, I'll go to the left-hand side and click Set from View, and it'll reset to our current view for our insertion direction. And I can take a look around, see how deep the undercuts are in any important areas. In addition to minimizing the undercuts on the contact walls, I also want to try my best to find an angle where I know I do have some other undercuts on other areas where I plan on having the retention. Like for flippers, I want at least a little bit on the lower half of the posterior teeth. And it looks like I've got some spots here and there. For a traditional partial, I'd also, in an ideal world, want to have a direction where I have undercuts deeper right at the tip of where the clasps are going to be placed. So if I was planning on putting a clasp on this premolar here, then ideally I'd want to try to find an angle where I have deeper undercuts right where my mouse is highlighting for where the tip of the clasp would go. Other than changing the direction using the Set from View button, you can also use these arrows to tilt in just smaller increments. So each time you click one of these arrows, it'll rotate by 5 degrees. And you can decrease that to move in smaller increments as well. But once I think I'm happy with that insertion path for our partial, we'll continue next, and it has a step where we can see the blockout that it's made and modify it as needed. From here, I'm going to turn on this slider so I can see that blockout a little bit more clearly. And it's up to us at this step to remove the blockout wherever we need that retention. So across all of these linguals, I'm going to use the minus tool to just expose those yellow undercut areas. If I do think that I've exposed a little bit too much, rather than using the add tool, I find the smooth is a little bit better at filling in just the deepest sections that I've exposed. With these tools, the minus tool in particular, it's not allowed to go below the surface of the model, so I don't have to worry about my circle size or strength too much as I'm reducing. And I'll come back and use the smooth tool to make sure the deeper areas aren't going to be engaged with quite as much. As I'm doing this, it's the only area I particularly avoid is the interproximal sides. Since those areas are typically not going to be flexible, I'm specifically leaving those blocked out. One last thing to note, while we will be designing clasps as part of the partial today, if you were planning on introducing wire clasps after the partial has either been printed or milled, the best way to leave space for them is at this step to use the plus sign tool and plug in a specific thickness of space you want. So let's say 0.8 millimeters. Because I plugged in a very specific setting, as I add and work my way back, you can kind of see it just stops adding once it reaches that 0.8 millimeter height. So you can just go in and leave a little space and a little bend for the wire to be placed and secured after the digital manufacturing is complete. But for this case, we won't be using that, so I'll hit undo. After the wax trimming and the undercuts have been exposed again, we can continue next. And because we've included a tooth as part of this, it takes us into Smile Composer next. If you've worked with the fixed restoratives for crown and bridge and implants, you're probably familiar with this layout for the tools that we're working with, because it pretty much shares almost all the exact same tools and functions as that workflow. The first thing we would do is decide, do I want to go off of an anatomy library, or do I want to copy one of the teeth from the scan? In this case, I am going to copy the teeth from the scan, but just so you can see, there are plenty of libraries that come preloaded, and this is not including any of the denture tooth libraries that can also be downloaded on top of this list you're seeing here. So to start off, even though I know I'm going to be copying this tooth here, that tool works better if this has been moved into the proper position first. So I'm going to use my transform tool and just click the tooth itself to pull it into place from a couple angles. I don't need it to be perfect. I just want it to be roughly filling in this area in the right way. Mostly using the red rotate and just clicking the tooth to shift around, but I might eventually use the green or yellow sliders to change the size a little bit. But the tool that I'll use to copy number 9, I'll go to Smart Tools in our third option, Mirroring. And here there's a bunch of different options depending on what type of copy that we're trying to do. And the one for copying the prep arch model, any teeth from that, is mirror copy from scan. With this, I first click on the tooth that's going to change. Then from a top view, I'll click the middle of the tooth I want to copy. And it'll come up with a border around that tooth so I can adjust and decide if I want to include or exclude different parts of the scan. But that preview that it gave me, the initial result, looks pretty good. And once I'm happy with that line, I'll just move my mouse around until I can see both purple arrows and just double click and it'll perform the copy. So the shape itself is copied exactly, but the position and rotation usually still needs a little bit of tweaking from here. So I'll go back to my transform tool and just shift or use the red sliders to tilt and reposition to get this more in line with where it should be. So we'll just rotate to a couple angles, make sure it looks good from each direction. And if you want to get even more technical, I could use this measurement grid to get an idea that everything's even across the midline. But let's say I'm happy with where that is in terms of positioning. The next things I want to focus on is how this tooth is making contact or leaving space between the tissue neighboring contact and occlusal contact. The best tool for reading that is going to be this color map tool, distance map. You toggle it on just by clicking the little dot here, and it'll show us a bunch of different colors on the surface of our tooth, whether the scans are visible or not. Anything that's the bright red means that it's not just touching the scan, it's poking through the scan. So this area is definitely way too tight in the occlusion, and I'm poking pretty far through the tissue on the underside and mesial distal sides. Everywhere else that goes from the orange to green is saying it's not quite touching the scan, but it's getting close. And how much gets highlighted does change depending on where I drag the slider to. So if I'm only concerned with things within 0.5 millimeter of a scan, I'll slide this around until it's close to 0.5. There's a little number next to the slider. It might be hard to see through zoom. But once it's at 0.5, I know this green area is right at 0.5 away from the opposing. So from here, I'll continue making adjustments. I like using the tweezer tool with its control key shortcut to let me reduce, just left click and pull down. But you can also achieve this by using the spray can, the wax knife's minus tool, to just reduce. Either way is fine, whichever tool you prefer. So when it comes to the underside and neighboring contacts, there are some automatic tools that you can try to use, but there are some limits to these. So if you go to the joystick icon on the left, the one in particular that I'm interested in is desired distance to gingiva. I would normally want there to be about 0.5 millimeter of a gap underneath this tooth to leave space and room for the base and the socket around this. But if I try applying this at the 0.5 setting, even if it did apply this all the way around where I want, it does tend to cut the interproximal sides a little bit more of a gap than I'd like. So a good alternative for this is with the wax knife. There's a function where we can have it stop reducing once we hit a certain distance. This feature is available for other designs, even in older versions, but for partials, it was introduced in the 2023 version. So with the minus tool in particular, I'm going to click on this button here called blocking wax, meaning that it's going to stop once it's within a certain distance of the blockout wax and model. The first value I'm going to plug in is very small. It's the space I want for my interproximal contact. So I'm going to put that around 0.2. And as I use the minus tool, it does not matter how strong this is. It's just going to stop reducing once I'm 0.2 millimeters away from the scan. And you'll notice that the color will not update until I let go of the mouse. So I'll just continue making adjustments, let go every once in a while just to give it a chance for the colors to update. So now everything should be 0.2 millimeters away from that neighboring teeth, which is perfectly manageable. Next, I'm going to change this setting to that 0.5 millimeter thickness that I want for the underside. And I'm specifically with this tool going to stay away from the contact sides. So I'm going to use this just on our gingival areas. And it's getting right to the deep green color, so I know I'm right at that 0.5 setting that I plugged that slider to. After I've reduced with this tool, I'm going to turn off this limiter function and go back to the smooth tool to clean up the edges of these sharp lines that have been cut into the underside areas, mainly smoothing a little bit extra on the lingual side. I'll go to a smaller circle size with a weaker strength and just smooth around the contacts, soften those sharp ridges. Might be easier to see with the color off. And then I'll come back from our facial view to make sure I'm not distorting the contour of this tooth too much. The last thing is technically optional, but I do like it for most of these flexible partial designs, is I do like to add a hole into the underside of the tooth so that a pin from the base can poke in and give it a little bit extra support for bonding together. The way to add that is with the attachments tool and using the holes section. You usually will have these circular holes available, but if you download the Zahn material library, we do have a rectangular option as well that I like for certain tools or functions. You want to make sure this pin always matches the insertion direction, so I'm going to choose that default orientation. Oh, I need rectangular hole. Click from the top, roughly centered where you want this pin to be, and get it to whatever rotation or angle you want. And from here, I'm going to make the tooth transparent so I can pull this all the way from the bottom and decide how high up I want this to go. Be a little bit lower. I can make this a little bit broader. That should be okay. Once I think I'm happy with that placement, when you hit this play button over here on the left, it'll cut away wherever that rectangle intersects with the crown or the tooth. So that is one of the features that is not available for the denture version of this workflow. But continuing forward, once I'm happy with the tooth design, I'll go next and it'll open up the RPD part of the workflow. Technically, almost all of these tools and steps can be skipped if it's not relevant to the type of partial you're doing. So for example, in this case, we aren't technically doing a traditional partial, so I don't need grids, I don't need this clasp tool, and I don't really need a finishing line. But just for practice to show the tools, I'm going to pretend that we're doing a traditional partial just in this one area. I can choose a type of grid pattern. I usually like the diamond pattern if I'm printing. Otherwise, for if I'm milling this out, I'd usually do circular patterns to accommodate the burrs. But you'll click this button to begin drawing and just left click around the edge of where you want that retention grid to be placed. Once the line is closed, you can click preview to see that result. And you even get more options if you click anywhere on the dots after this. You can pull around where the pattern gets applied and what rotation and direction that's pointing in if it's relevant to that pattern. And then preview again to see the new results after the adjustment. In addition to the grid itself, it is adding a resin gap spacer underneath that grid based on this value here. Continuing next, the only tool that I'd say is required across this is one of these two here to either draw a major connector or a lingual bar. So major connector is essentially going to be our base for most flippers or flexible dentures. As I begin drawing this, I'll just start left clicking around. And like a lot of drawing modes in 3Shape, if I have a misclick at this step, like I accidentally click somewhere I don't intend, I can't move or fix this yet until the line is closed. So I'm just going to ignore it and keep working my way around. I know once I come back to this, once I've closed the line, I'll be able to clean that up however I need. So we'll just get this filling in, not really engaging with the teeth too much on the anterior section. And once I get to the posteriors, I'll go up onto the body of the teeth so I know that I'm engaging with at least some of the undercuts. And you can decide however far back you want that to go. I'm going to just have this be a horseshoe shape, just wrapping around a little distance down on the tissue. And in the area where we're treating this like a traditional partial, you just want to make sure that this is overlapping and intersecting with the grid at least a little bit to make sure there's a strong connection to the major connector. Now that I've worked my way around and clicked on my very first dot to close the line, I can come back to any problem areas and just grab and move around the dots. I can add new dots or delete ones I don't want, however you want to handle that. Around the tooth in particular, I just need to make sure I raise up into the interproximal area because at later steps, I'll be able to change the thickness of the major connector or the base, but I won't be able to move where the edge of the base is. So I want that very specifically at the height of where I want the tissue to go for that interproximal section. The next thing you'd want to adjust is the setting on the left for how thick this major connector should be. Because these settings are more geared towards traditional partials, the maximum I'm allowed to bring this to is 1.5 millimeters at this step. Though at later steps, I'll have access to sculpting tools where I'll bulk this up a little bit further. Usually I'm going for somewhere between 2 to 3 millimeters for most of the milled acetals or the printed denture materials for the bases. But one last thing is if we had any occlusal rests or stops, you can also use this button here to go and draw where you want that to create that vertical stop, or any other minor connectors you could create with this tool as well. Continuing next, it moves on to the clasp step. Again, for the flexible partials, I usually just, if I'm including a clasp, I'll draw it as part of this major connector line. But for a traditional partial, to get the really narrow tapered clasps, you usually do want to use these clasp tools to create them. There are a bunch of different presets that this tool has available for different clasp shapes or sizes, but because of some shortcuts I'll show you, you can add almost anything as this default G clasp option. So I'll click this button to begin drawing. I'll choose where I want the connector to start, work my way down through where I want the tip of the clasp. And to finish this drawing, I'll just click a second time on my final dot. From here, I can move around the dots, but the main thing that I want to do is change the size and taper of this with a couple shortcuts. If I hold down the Shift key, it tells me the width and some other measurements around each section. And while I'm still holding Shift, I can use the scroll wheel to taper that down to adjust how thin that is in that segment. The other shortcut would be holding the Control key on the mouse. And similarly, I'll use the scroll wheel, but this time I'm adjusting the thickness or depth of that part of the clasp. You can also hold down both Shift and Control at the same time. That way you're tapering in all directions to whatever thickness you want. I also find that I like to remove some of the points, and that tends to give me a smoother transition. And because of this freedom and how we want to draw or change the clasp shape, like I mentioned, you can create pretty much any type of minor connector you want with this. For example, if I was looking to create a roach clasp, I could click this and draw one line that acts as the clasp itself, and then click again and draw another line that acts as the jumper bar. Other than needing all of these different shapes to be overlapping and connected in some way, there are very few limitations the software puts on the ways we draw or create these shapes. But I'm going to delete these, just right click and delete spline. And for this, I'm not going to draw any additional clasps for the flipper part of the workflow. Continuing next, there is a sculpt step that gives us access to the wax knife tool with the plus minus smooth, and there are some things that I do want to use this tool for, but I like to wait until another sculpting step that comes a little bit further ahead. So for right now, we'll skip this sculpting step and continue to this finishing line step. For a flipper, this is another step that we would skip as well, but for a traditional partial where you do have retention grids, it's automatically got the finishing line on the gingival side, but on the top side, we need to add that finishing line. So we'll just click here to begin drawing. Click a little bit in front of or behind the underside finishing line that it's showing us with this green line highlight. And then decide where exactly we want that shape to end. This time I got lucky, but sometimes the line can be reversed. So if it was facing the wrong direction, like this, you can just right click on any part of the line and use this reverse option to flip what side that's pointing to. But after this, once we placed all of our remaining minor connectors or other shapes, we'll continue next to close to the end of our design, where we have that other sculpt step that I mentioned, where we have access to the wax knife, and we also have access to some other tools that we're going to be using as well. Generally, my first order of operations at this step, both for traditional and for flippers, I'm going to be smoothing for most of that. So for the flippers, I want to use the smooth tool to get rid of these rough textures, kind of give myself a cleaner canvas to start building on top of. So we'll just use the smooth tool all around to get rid of and soften those details. For traditionals, I am also going to smooth, though I have to be a little bit more specific with my size and strength for this tool, because especially on narrow areas like the tip of clasps or on the grids, the smooth tool does tend to make that really, really thin very quickly. So typically the areas I'm smoothing are just the intersection between any different connection or piece. So just softening the separation between those parts. The next thing I want to apply is how thick I want the material to be in general. The best way for me to gauge that is to use this thickness map tool, where just like that distance map from earlier, I can drag this slider and it'll highlight a different degree depending on how thick I set this value to. So let's say I want to make things at least 2 millimeters thick on average. I've moved the slider until it's at the 2 value, and now I can go in with the add tool to fill in the areas that need it. Similar to the previous tool, if I keep holding down left click and never let go, the color never has a chance to update. And when I do let go, it might mean that I've added way too much. So with this and most tools in general, you don't want to make too many changes with just a single click. So I'm going to let go of the mouse every once in a while, just give it a chance to update. So we'll just go around making sure the main body of our major connector is thick enough for whatever material we're working with. Make sure to check the instructions for use document to confirm what thickness the manufacturer recommends. And on any parts of this that are getting narrow, most materials usually do want you to have those be a little bit bulkier during the milling or printing process, even though you typically would go in and taper that down manually once the printing or milling is done. That's true of acetal, and that's true of most of the denture-based resins that you'd print out of. The next area I'll start filling in is around the tooth itself, so I have some buildup around it for the socket. Right now, it has not created the socket shape, but we will be creating that towards the end of this step. So I'll fill up around that, and I don't generally want to go too much higher than wherever the height of contour is around this tooth. And depending on how much material you're including for the partial on the facial or buccal sides, you may get into more or less detail for the anatomy around the tooth. So I could go in with a smaller plus sign tool if I wanted to try to do a little bit of festooning, but I don't have a lot of vertical space for that in this case. Tissue is not receded to a crazy degree for this patient. But you'll fill in however much you want. The next area I want to fill in is actually inside the tooth, so I'm going to make that transparent. This is only necessary if you did create the gap on the inside for a pin. If I do not add and fill in this pin at this step, the pin will not go all the way up to its highest depth inside the tooth. So this shape is going to get cut away in a moment anyways. I'm just filling in, making sure the pin will extend all the way through the tooth to where I've defined it earlier. If I did go too far, you might notice a green spot like this, and you can either minus or smooth to get rid of that. As long as the pin itself is covered in that transparent view. The next tools you might use, they're optional for the majority of cases. There's a stippled wax texture that can be applied. Most of the time, this is geared towards traditional metal frameworks, but there are some times where I might use these for certain opaque materials for the flexible partials. For dentures, they have this denture pattern where you paint the area where you want this to apply. And when you hit play, the denture pattern adds little pock marks that just break up the smooth, solid surface a little bit. To some degree, that will get polished away once the manufacturing is done, but it just can help a little bit with the materials that are very opaque, just to break up that smooth, plasticky texture. Some other patterns that can get applied, we've got type 1, which adds a vein texture, and you can control how prominent that is by changing this height value. Oops, 03. So it'll be quite a bit more subtle in this case. And type 2 and 3 are your more traditional kind of coarse texture for metal frameworks and those major connectors. With any of these textures, if you decide to modify it after the fact, you absolutely can. You can just go in and smooth however much you want by continuing forward. My strength is a little high, so it did wipe that away. The other optional tool we can use is an engraving. This tool is only really possible for printed manufacturing since a milling machine has a hard time getting at text. But we can type in whatever we want, like the patient name, decide how deep the engraving should be, click the plus sign to decide where that name starts. Let's say over here, and then use the red dot to rotate that to whatever direction we want that angled. Once we hit the play button down here, it will just cut that 0.4 millimeter distance into the surface of our design. But the very last thing we should do at this step is create the socket. So I'll go to this little joystick icon, and the tool in question is this one here, create pockets for teeth. It is set to 1/10 of a millimeter spacer, which is generally what I find most labs like for the fit between the tooth and the socket. But depending on what material or bonding agent you're using, you may want that a little bit tighter or a little bit looser. But 1/10 of a millimeter is the average. I'll hit play, and it'll cut away wherever this tooth intersects with the major connector shape that we've sculpted. So the reason we had to be so specific earlier about the distances on the interproximal and the underside is if the tooth was poking too far, this step has no issues with it creating a hole through the socket. So we just need to make sure we gave it enough clearance for that. Like the other tools, the software does not protect this shape. So if I continue using the smooth tool and I'm not careful, I can go in and wipe away the socket details, which will ruin the fit. So if I did need to make a change, it's better to undo, make your adjustment, and then come back and create the socket once you're ready. After that, we're in our final step for changes. The only two things we typically do at this step is this first button for traditional partials. This will let us add tissue stops. So like on this grid here, I can just click where I want there to be a tissue stop, and it'll be 4 millimeters wide. I'll preview if I want to see that result. And I can see how it's adding that little tissue stop underneath the grid. The other thing we can add at this step are support pins, and these could be added for a couple different reasons. For traditional partials, we typically add these pins as the start off for sprueing for the investment process. So I can click a couple different points and these pins will snap together. And once I've placed them, I can grab that end point and decide what direction the investment is going to be coming from. For the printed manufacturing methods, we typically use these pins as a support bar. This is not for the manufacturing process, for either printing or milling. This is more for stability during the curing process to make sure things don't warp in the curing units that expose the material to heat. So depending on how far back this is, I at least want a pin going on the most posterior sections running to the anterior. But I typically, for a longer U shape like this, I might add another pair of points. Just for some extra stability. Additionally, you can use the scroll wheel shortcut over here to taper the tips of these a little bit thinner so that it's easier to break off once the curing has been completed. But after that, once I'm happy with these final additions, I continue next, and I'm at my save step of the design. The files that'll get output for this case is I'll have one main file for the base, and then there will be a separate folder with individual files for any teeth that I designed. But at this point, I'll open up the floor. Let's take a look at if anyone has any questions. If you think of anything, we'll still be around for a little bit, so make sure to jot that in.
Alex, I want to thank you so much. The design
Absolutely.
looks great. And again, we're open for any questions. I will launch our last poll question for you all to answer.
Mhm.
And this one is if you're interested in coming to our Wakefield, Massachusetts technical facility to join Alex and Matt to do a hands-on intensive design course on digital dentures as well as removable partials and flippers. You could let us know as soon as we get a date. We will get in touch with you. One of us definitely will, and we'll give you all the details on how to get to us. I just want to let you know what's happening next on Zahn Academy. Next week, we have the fabrication portion of metal-free removable partials and dentures and flippers featuring Meyerson materials. So now you got the design down pat. Now we're going to get to fabrication and printing. So that will be hosted by Chris Schermerhorn, who's a CDT and the owner of Northern Virginia Dental Laboratory. So that's next Wednesday, December 13th, 2 p.m. Eastern, and registration is now open for that course. So please join us next week. On December 20th, we have designing of premium dentures in 3Shape. That is the following Wednesday, 2 p.m. Eastern, December 20th, and registration is now open for that one as well. So we're so excited to actually be able to bring you the third portion of this 3Shape design course that we have.
Hello, and it looks like we have a question from
Yes.
Carlo. He's asking, can we place these support bars through the model? That is something that I would like to do. Unfortunately, I have not been able to find a way to achieve that without using the attachments tool. The reason we'd like to add these support bars through the model is especially for the milled acetal material. These clasps can bend very easily during the milling process, so sometimes we would like to have a support bar running between these spots. But typically what happens after I've drawn this point, if I continue next, it is going to cut away with wherever this shape intersects with the model itself. Yeah. So it won't allow me to create that, unfortunately. It is something that we've requested from 3Shape, so they typically will take that into account as they go into future versions.
Any other questions out there for Alex? Okay, I want to thank everybody for joining us here at Zahn Academy, and we look forward to seeing you next week. I just want to make everybody aware of our financial services packages that we have for you out there. It's getting to the end of the year, and because of Section 179, you're able to bundle a few of our financial services packages along with that, where you would be able to write off any equipment that you buy before the end of the year. So if there's anything that you're thinking of, now's the time. Please contact one of your Zahn representatives and they'd be able to help you through it and get you in touch with our financial services representatives. I want to thank you all for joining us here at Zahn Academy, and we look forward to you joining us next time. Have a great day, everybody, and hopefully we'll see you next week. Thank you so much, Alex.
Absolutely, and thank you again, everyone. If anyone has any other questions, feel free to reach out to our support team, and you can ask for Alex DeVos. Thank you. Have a good one.
Thank you so much, everyone.